Welcome to the InventorCAM Professor video series called Jumpstart, the easy way to learn InventorCAM. Let's start off with part 1 of our first lesson in InventorCAM, where we will create a milling cam part. Here we'll be familiarizing you with selecting a CNC controller to handle our G-code output, creating a home position or coordinate system for the part, adding stock material to the part, and finally defining our target model. First, we'll need to open our example Inventor part. Please note that this part file does not come with the installation of InventorCAM. The example file will be included with this video tutorial. I placed this file in a training folder that I've created on my C drive. I recommend you do the same. Now, let's open Inventor. Go to the Getting Started Operation ribbon and select Open. When the dialog opens, let's look in the C drive under Computer. Select the training folder from the list, and then choose the simplecover1.ipt and open it. Before we begin, let's disable the automatic cam part definition for both the stock and target. By default, these settings are enabled. Go to the InventorCAM Operation ribbon and select Cam Settings. Go to Automatic Cam Part Definition in the list, uncheck Definition of Stock and Definition of Target. Then click OK to close the dialog. Here we have this simple cover ready to go into InventorCAM for programming. We need to create a new cam part using the InventorCAM Operation ribbon. Click on the new icon and select Milling. This new milling part dialog handles the saving of our CAM project. The first field shows exactly where the part will be saved. This can be controlled either by going into the default area of our InventorCAM settings, or by simply clicking on Use Model File Directory and storing it in the same folder as our Inventor model. Our second field will be giving us the name of our CAM project. InventorCAM uses the Inventor part name, simplecover1, as a default and uses a compressed cam part file extension, .prz. Finally, our third field is just showing us exactly which Inventor part is being put into the CAM project. When we click OK, it brings us to our milling part data. Our first step is selecting a CNC controller to handle our G-code output. In this particular case, we will use a Haas G-milling post as our CNC controller. Next, we will be creating our coordinate system, also known by many people as their home position. By clicking on Define, it opens up all the options needed in order for us to create our home position. As we see here, we have 4 different options of how to create our home position. We'll start with our first option, and also our most used option called Select Face. By choosing Select Face, the moment we click on a specific face, the home position or coordinate system will be created with the Z-axis perpendicular to that face. Now, in this particular case, we will select Top Center of Model Box from the Place Coordinates Origin to dialog. We will get into these other options later. Now, when we click on any surface of our part, it will automatically create a home position at the very top center of that surface, as shown here. The coordinate system axes are represented graphically by color. The x-axis is represented by the red line, the y-axis by the green line, and the z-axis by the blue line. Let's click Finish to accept our home position. This will bring us to our next window where we can control our levels. Let's quickly run through what these represent. The tool start level is the level where the tool comes to directly after a tool change and where the tool length compensation is activated. The clearance level is the level where the tool will retract to when moving from one area of the part to the next. The part upper level represents the upper level, and the part lower level represents the lower level of the part. We'll accept these default Z levels by clicking OK. We have just created our first home position. Let's click Finish to accept when the CoordSys Manager appears. Now, our next step is creating and defining our stock. There are several ways of creating and selecting our stock in InventorCAM. For the purpose of this exercise, we will use our most common option called Box. By selecting a surface on our part model, it will automatically create a bounding box around the outside of our target model. We have control over how much material is added to the target model in 6 directions. So, for example, in our X plus and X minus direction, as well as our Y plus and Y minus direction, we'll set it at 2 millimeters past the part. In our Z plus direction, we'll add only 0.5 millimeters of stock material to the top of our part. Lastly, we will add 5 millimeters in the Z minus direction so that we have material to clamp onto when we are machining this part. As we alter the numbers in the input field text boxes, the stock material is updated graphically in real time. Once we have these dimensions set, let's click on Add Box to CAD Model so that we can continue to see this box representing our stock throughout the lesson. We can accept our stock by clicking Finish. Our stock is now complete and we can move on to defining our target. The target is basically used for certain simulations that we find it necessary to use the target operation, which we'll explain a lot more in detail as we go on through our lesson videos. To create our target, we begin by selecting the Target button. Click on Define 3D Model and select any portion of the target model. It will be listed here as Solid 1. Our target is now successfully defined. By clicking Finish and then OK, we move back to our original window. Let's now click Save and Exit and move on to our InventorCAM Manager. Now we can begin adding toolpath to machine our part. And this concludes part 1 of our first lesson in the InventorCAM Jumpstart Series, where we've created a milling cam part. Thanks for watching. Please join us for part 2 of our first lesson, where we will add a face mill operation and go through the operation dialog.